Okay, this is a question about limiting reactant. I'm going to do a pictorial version of limiting reactant just so you can see what is happening. This does not involve any calculations with stoichiometry, but just to get a sense of what limiting reactant means. Let's say I have a given equation here. This is hydrogen H2 plus nitrogen N2 forms ammonia, which is NH3. And typically, if you remember this equation here, this tells me that three molecules of H2 will react with one molecule of N2 to form two molecules of NH3. So everything has to react in these ratios in order to get the molecules that you want. Now, a lot of times in chemistry or in real life, you don't have exact amounts of these things. And so one of the things is going to run out before the other, and this is where you have a limiting reactant case. And so in the question on your handout, there are 3 molecules of H2. There are 6 molecules of H2 here. 1, 2, 3, 4, 5, 6. There are 12 molecules of N2, and the question is, how many molecules of NH3 are you going to make, and what is your limiting and excess reactants? So to do this question, I'm going to start circling groups of NH3 because when you have this reaction take place, the hydrogen bond, H2, the covalent bond between the two hydrogens will break apart. Same thing with the nitrogen, they're going to break apart and things are going to start shuffling around and reforming. So every time when this happens, stuff's going to break apart. I'm going to form an NH3 here. So this is an NH3 group here. So 1 nitrogen and 3 hydrogens are going to come together to form an NH3. Likewise, another. So this nitrogen is going to come together. And this is not, everything kind of breaks apart and happens in a container, but not all the nitrogen is going to get used up. So I'm not going to start taking different nitrogens unless they're going to react. So this nitrogen would come together with these 3 hydrogens. Maybe this one would come here with another 3 hydrogens. And you can see that I'm only going to be able to form 4 ammonia groups with this amount of hydrogen. So on the right-hand side for the after, I'm going to have an NH3 group. I'm going to have 4 of them. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nitrogen groups left. So I have N2 times 10. And so, as you can see, I can only form 4 groups of NH3, and I have 10 groups remaining. So, because the hydrogen ran out, I say my hydrogen over here is my limiting reactant. And my nitrogen over here is my excess reactant. And if I'm counting up the number of things before and after, I used up 6 molecules of H2. I used up only 2 molecules of N2 to form 4 molecules of NH3. And if you refer to the top here, this is the same ratio that we had the original equation, 3, 1, 2. Instead, I just doubled it, 6, 2, 4. And so you can see how everything stays in balance.